Okay. This is test review 3. Behind me is a tank of water. And in this tank of water there is a iron weight that's sitting on the bottom. There is a piece of wood that's floating. And the wood is partially submerged, like all wood. It's floating with just a small amount beneath the level of the water. This is completely submerged. Now, let me ask you a few questions. Which has greater density and why, by looking at that drawing, the iron or the water? What has a greater density, the iron or the water? Anybody?
Iron.
The iron has the greater density, and why is that?
It sinks.
It sinks, okay? Less dense floats on more dense. That make sense? Okay, good. Now, what is the apparent weight of the iron equal to? What is the apparent weight of the iron equal to?
The amount of water it displaces.
No, the amount of water it displaces is simply a volume. I asked you for a weight. What's the apparent weight? It's not a volume. A volume is a volume. But what are you trying to get at? What's the volume it displaces? What does that have to do with anything?
Got mixed up.
No, you're on the right track. You're getting there. Nick.
Would it be the weight of the water displaces?
The weight of the water displaced, okay, but isn't the weight of the water displaced the buoyant force? I'm asking you for the apparent weight. In other words, I'm not asking you for the weight of the iron in air. I'm not asking you for the buoyant force. I'm asking you for the apparent weight in the water. Emily.
The weight something feels when it's underwater.
The weight something feels when it's underwater. Okay, that's the apparent weight, but how would you get that? What would you do? What two things would you add together to get the apparent weight?
The buoyant force.
Buoyant force and
The weight.
the weight of the object in air, correct? Which direction is the weight?
The weight goes down.
The weight goes down. That's the weight. That's the buoyant force. And for the iron, the weight would be much greater than the buoyant force, wouldn't it?
Yes.
Yes? So isn't the apparent weight the same thing as the net force?
Yes.
Isn't it the same? Okay, so we can say that. We can say that apparent weight equals the net force equals the sum of the buoyant force and the weight. Does that make sense?
Yeah.
Okay, now let me ask you this. Which has a greater buoyant force? The iron or the wood? What has a greater buoyant force? The iron or the wood? Why would the wood have a greater buoyant force?
It floats.
It floats,
Yes.
okay, but what does the word floating mean?
Buoyancy.
No.
No.
What does the word floating mean? What's the definition of floating? Floating. I'm going to write it right here. Definition of floating. What's the definition of floating? Isn't that true? The buoyant force and the weight are equal. So what has a greater buoyant force? The wood or the iron? Think. What is the buoyant force? Define for me the buoyant force. We just did it. Nick.
The weight of the water, what the object displaces.
Right, so the weight of the volume displaced, right? What's displacing more water? The wood or the iron? The iron. So the iron is displacing a larger volume of fluid, right? Therefore, what is going to have a greater buoyant force, the iron or the wood?
Iron.
The iron will have a greater. So how do you know that? Well,
Because the iron sunk.
well, no, not because the iron sunk. That's not why. That's not how you know. You know what has the greater buoyant force. It's very simple. It's the one that has the greater volume, that's submerged. Correct? Right?
Yeah.
Is this going to displace more, that little block of wood, is that going to displace more water than a giant battleship? No. The giant battleship will displace more water. Correct?
Correct.
So which one's going to have a greater buoyant force? The giant battleship. It's floating, therefore the buoyant force and the weight are equal. Heavier weight, heavier buoyant force, correct? Now let me ask you this. Now we're almost done. What's the apparent weight of the wood? What's the apparent weight of the wood? What is the apparent weight of the wood?
Yeah,
This is HESPA week, can you tell? What's the apparent weight of the wood?
you have the equation.
What is the apparent weight of the wood? You can give me an exact number based on that drawing. 0, yes, because it's floating. What is the apparent weight of anything that floats?
0.
0. What is the net force of anything that floats? 0. You get it? You sure?